Hi, this is an introduction to logic. I'm Mark Thorsby, and this course overviews the basic concepts in categorical, propositional, and predicate logic. Today we're going to be taking a look at Venn diagrams in the traditional standpoint. Or in other words, how to use Venn diagrams if we go on board with the Aristotelian perspective concerning the existential fallacy. Okay, and of course, for a detailed review, please watch earlier videos and you can see exactly what we're talking about. But I will start off here with a sort of brief elementary review. And here's what I want to talk about. I want to begin by reviewing the concept of validity. And hopefully by this point in the course, you've sort of memorized what a valid argument is, or you've memorized rather what validity means. Remember, a valid argument is an argument whose form is such that if the premises are true, the conclusion necessarily follows as true as well. Whereas invalid arguments can have true premises and false conclusions. So there are valid arguments and there's invalid arguments. Today we're going to begin, and we've mentioned this before actually in the past, by problematizing the view that there's just valid and invalid arguments by offering a third or a middle ground, which means there's really two types of validity. On the one hand, the most substantial sort of validity is what we call unconditional validity. And another thing to mention here is that unconditional validity really only applies, at least in this point in the course, only applies to categorical logic. If there's unconditional validity, there's also conditional validity. And the difference really consists in how we understand the existential fallacy. I'll just put it. And remember, the existential fallacy is the idea that if you make an argument about things that don't exist, you commit the existential fallacy. But there's a debate here between Boole and Aristotle. And again, we've already covered this, but it's so important and so pivotal. I think it's critical to go over it again. And the debate really is between John Boole and Aristotle. And the question is whether or not universal statements do universal statements imply existence? Boole says no, they don't, which means that if you make a universal claim, for instance, all trees need water, right? That's a universal, that's an A statement, that's a universal claim. But his argument was that you can never know for certain if your universal claim is actually true. I mean, I'm simplifying it here, but ultimately that's what it comes down to. Because I can't go everywhere in the universe to make sure that all trees really need water. Now, that seems sort of counterintuitive because it seems obvious by definition trees need water, right? So what Boole says is that when we make universal claims, there is no claim of existence in the universal, which means that a universal statement that's true doesn't necessitate that a true particular conclusion if it uses the same terms. Okay, so that means that for Boole, if I say all trees need water, therefore some trees need water, that actually commits the existential fallacy because there's no truth claim of existence in the universal for Boole, right? So the existential fallacy is the strictest here when we talk about Boole. Aristotle, by contrast, didn't think that was the case, or rather, he never really conceived or argued against that. He argues that we can know universals, and then when we make universal claims, those claims, if they talk about things that actually exist, do make claims of existence. So Aristotle would take probably what for most of you watching would consider to be the sort of common sense view, right? Is that all trees, when I say make the claim that all trees need water, that claim in fact does imply the existence of trees, which means that for Aristotle, you can go from universals to particulars. The universals contain within them the information known for particulars, whereas Boole says there is no such claim. The universals don't imply the true functionality of a particular claim. Okay, now why are we going over this? We've looked at in our last lecture here, we took a look at the traditional square of opposition, a sort of medieval device meant to represent the various relationships between the four primary categorical types of statements. And when we were taking a look at that, what we discovered here, and now we're going to move down here. Here is that square of opposition we looked at last time. Here is the A, the E, the I, and the O. These four statements. And the square of opposition stipulates that the diagonals here are contradictory relations, such that the I and the E can't be true and false. I mean, sorry, if the I is true, the E has to be false, and vice versa. They can never be the same, have the same truth value. Um, but we're but what did Boole say? Boole's thought that since universals, and because of this business about the existential fallacy, that these these horizontal and vertical relationships, that these relationships were unknown from Boole's perspective. Whereas Aristotle says, no, there is a logical relationship. Again, because it all stems from the way he conceptualizes this existential fallacy. That means we get subalternation, which means that truth flows down and falsity flows upwards, and then we get the contrary and the subcontrary relationships. I encourage you to take a look at that video again if you forget what these are all about. And we've talked about this in our last video. What we're going to do today is ask the question, what about Venn diagrams? Okay, so let me draw some Venn diagrams. A couple of sessions ago, we did look at Venn diagrams, and this is sort of a refresher probably for some of you. I'm going to draw these Venn diagrams here, where this is the S and this is the P, right? Remember, the A statement says that all S are P. Remember the key here, maybe I should write it down here so you can remember. The key is if you fill, that means there's nothing in the filled space. If you put an X, that means that at least one exists. Okay? Now notice here that when I fill in this circle here, that means nothing's there, which means that all of the S's, that's what's ever in this sort of football shape here, are also within the general P circle. All S are P, okay? Now, what does the E statement look like? The E statement looks like this. You fill in the football. That's what I'm going to call that middle spot. And this statement says no S or P. Okay? No S or P. And then let's go down here. When I say that there's the S and the P, the I statement, do you remember? Some S or P. We put an X right here in the center of the football. And then over here we draw, the last one here is some S or not P. Sorry, I'm running out of room here. I'll put the S and the P up here, the labels. And this looks like this. The X's are here because at least one of them is not a P. So that's essentially how we've diagrammed the Venn diagrams previously. But here's the question. What about the A in the I statement? What if I make an all S or P and then some S or P as an immediate inference? For instance, to give you a sort of real example, what if I said that all frogs are amphibians, therefore some frogs are amphibians? Okay. Now, obviously, I've done a subaltern immediate inference here because I started with an A and I concluded with an I, where I said if this is true, this will be true too. But now let's take a look at the Venn diagrams. Notice the question is, how are we supposed to use Venn diagrams when we test immediate inferences? And this will become very important later on in the next chapter. We test them by asking this question: can I read the conclusion from the premise? And that's such an important question here that I'm just going to write it down because you really need to remember it and write it in your notes. Can I read off the conclusion from the premise? You should always ask yourself that question. And the answer is if you ask this question and you cannot read off the premise, then that means it's an invalid inference. If you can read it, that means it's a valid inference, okay? Now, the way I have it looking right now, take a look at this. All S are P, therefore some S are P. Right now, I cannot read this conclusion from this diagram because in order to read this conclusion from the diagram, here, I'm going to use a different color. What I need is a little X here, right? That's the only way I could see this. But since there was no X, right? Since there was no X in the way we originally drew it, that means that I can't know. I cannot read it, so it looks invalid. Okay, so obviously it is valid from Aristotle's perspective or the traditionalist perspective. So how are we going to correct this? And what we're going to introduce here is what I'm going to call the existential marker. Okay. And the existential marker is simple. It's an X with a circle around it. I guess it's sort of the X-Men symbol, actually. But now, strictly speaking, this X here is also an existential marker. Because remember, an X means at least one exists, right? But the existential marker with the X with a circle, it's only going to be located up here at the top. And it's going to go in the middle. And then this one's going to go here. Okay? Because now if we look at these Venn diagrams, this truth relation, you can read this from this. So if this is true, you can read this. And if this is true, you can read this. Truth does flow downward. You can read the Venn diagrams. Now, some of you might be wondering, well, wait a second. What about the false to this, right? If this is false, does this work here? Kind of and sort of. We're going to talk about that. There's going to be a special rule here when you're evaluating false statements, okay? And it's going to involve converting them into contradictories. So that may sound a little confusing, but I think by the end here, when I do the example, it's going to make sense. So once we introduce this existential marker, what we get here is we get the traditional square proposition matched up with Venn diagrams that are made to do proofs from the traditional perspective, okay? And so you can see here they've added this existential marker in each of these cases, okay? And so what you're gonna see here that when the real question is how do we use this in assessing categorical arguments and assessing immediate inferences. Now in chapter 4 we're not looking at arguments, we're just looking at immediate inferences. So let's move to that now. Okay, testing immediate inferences. How do we test an immediate inference? Okay, here are the steps you're going to take. The basic steps to test the immediate inference using the Venn diagrams from the traditional perspective. 1, you're going to diagram both, whoops, that's not supposed to be an E there, but I'll leave it. Diagram both the premise and the conclusion. Okay. 2, here's a second step. If one of the statements is false, namely it says it's false, such as this one is false that some A or B, then you have to diagram the contradictory of it. A good rule of thumb is never diagram what's not the case. Only diagram what is the case. In fact, that's actually a good rule of thumb for anything in life. Start with what is known to be true. Truth. Always work towards truth. Don't try to diagram what's not the case or what's false, okay? So let's put here, the second step here is convert any, I'll put false here, any false statements into their contradictory. Into their contradictory form. And let me see if I can explain that, okay? So let's start with this. And then, well, I'll finish it off, the steps here. And then the third step is ask the question. Can you read the conclusion from the premise? And there's going to be a fourth step here, and I'm going to write it down and we get that. So let's use this as our example to start with. Excuse me. Okay, it's false that some A or B. Now, I need to diagram this, but I have these false statements. In fact, this one's false and this one's false. So I need to diagram these, right, into their contradictory form, which means that let's remind ourselves we have the A, the E, the I, and the O, right? Remember that the diagonals here are contradictory relations. Okay, so let's take a look at this. It is false that some A or B. So that's a I statement, right? So if this is false, then the E statement is true by definition. Okay, so that means that I want to actually diagram an E statement, which is going to be that no A or B. Okay, and then let's take a look at this one. It is false that all A or B. If this is false, then the O must be true. Okay, so the O statement looks like this. Some A are not B. Okay, so now what we're going to do is we're going to create diagrams for each of these two statements. So let's start with the first. Okay, the first statement, no A or B, and remember, always label, looks like this. No A or B. Okay. And then the second, this was the premise, and sometimes it's helpful to keep those straight if you need to. And then the conclusion was that some A are not B, which looks like this. All right, and this is the conclusion. Okay, so now we've done our second step. So the third step is, can you read the conclusion from the premise? Right, here's the conclusion, here's the premise. I cannot read the conclusion from the premise right now. Why? Because in order to read this conclusion, I need an X up here, okay? So there's a fourth step here. The fourth step is add your existential marker and retest. Okay, so let me add the existential marker. That's the X with the circle in it. And remember, if we go up here, the existential marker only happens in universal statements, right? Because it's meant to say that we're assuming that the universal claim here makes a claim of existence. So you never ever put an existential marker in a particular claim here down at the bottom. It's only at the top. So you can see here, that means if I'm going to add the existential marker, I have to put the X with the circle around it right here. Put my little X-Men symbol there. Now I retest. Can I read the conclusion from the premise? Well, now I can. Because look, the X is here, right? And then this is here and this is here, okay? Which means that the X does carry through to the conclusion, which means that the premise is sufficient to support the conclusion. So is this argument valid? Well, it's not unconditionally valid, because if you pass the third test here, it would be unconditional validity, Boolean validity. But here, since I had to add this existential marker, this turns out to be only a conditionally valid argument. It's conditionally valid. And what is it valid upon? It's valid if I assume that the universal makes a claim of existence. Now, it's an important here because when you do these in the homework, remember that you don't want to, this is the existential fallacy in terms of how Boole and Aristotle understand it differently. But remember, if you get arguments about unicorns and stuff like that, that breaks the existential fallacy for both Aristotle or Boole. Okay, so those would be invalid arguments. Okay, so that's how you test immediate inferences. Maybe we should do one more here just to give an example here. Let me see if I can find it. So here what we're taking a look at, this is your homework. So let me scroll down and let's do a different one here. Okay, let's do this one right here. Let's do number 8. Okay. Let's go up here. Oops. Okay. Oops, sorry, it's sort of in the middle there. But that's all right, who cares? Okay, so the question is, what about this argument? It's false that some A are not B, therefore some A are B. Now, if you want, what I encourage you to do is actually pause the video and do this problem on your own, and then watch it and see what we come up with. Okay, obviously I'm not going to pause it. So, how are we going to do this? Now, the first thing to do is to diagram it. Look, I have an it is false that, so that tells me I need to diagram the opposite, right? A-E-I-O. That is a some A or not B, that's an O. So if this is false, then the A is true. So what I need to diagram is actually an A statement, okay? So the A statement looks like this. If it said that all A are B, then that would look like this. Okay, I'm going to circle out that. And remember, always label. That's the premise, so let's do the conclusion. The conclusion is therefore some A or B. That's quite simple because we're assuming, remember, if it doesn't say it's false, we're going to assume that they're saying it's true. So saying we have a true one here, right? So that's an A and the B. And you put the X there. Now, can I read the conclusion here from the premise? The answer is quite obviously no, I can't. So it is not unconditionally valid. But let's now retest after we add in our existential marker, okay? Our little X with a circle. Okay. Now ask the question, can I read the conclusion from the premises? And the answer is yes, I can. I can read it because here's the X and there it was before. So that means it's conditionally valid. So this is a valid argument, or valid from Aristotle's perspective. Okay, so that's how you do these immediate inference argument tests, by using Venn diagrams from the traditional standpoint. Remember, the critical things that a lot of you are probably going to get maybe tripped up on is, remember, don't diagram false premises. Convert those statements into the contradictory of them, right? Because you only want to look at what is true, okay? And that's how you do Venn diagrams from the traditional standpoint. And you're going to see that by the end of the next chapter, that there, because this may seem sort of kind of, maybe sort of kind of, I'm not sure what the word is, maybe too nitpicky actually. But you're going to see that by the end of the next chapter, chapter 5, that this existential marker in Venn diagrams is actually really important for actually testing the validity of categorical arguments. So anyway, that's what we've done this time. You'll see that our next video, we're going to jump right into chapter 5. I encourage all of you to read, 4.7 in Hurley's book, where he talks about how do you translate ordinary language statements into categorical form, and he gives you some good advice about how to look at singular propositions, adverbs and pronouns, and things like that. Some helpful ways of doing translation. We're going to skip that for now in terms of the video series, but I highly, highly encourage you to read that. Okay? So that's what we have going on now. In our next chapter, we're going to look at 5.1. We're going to be looking at categorical arguments. And things are going to get fun, okay? Thank you very much for watching, and I'll see you guys online, okay?